Um, Hi. Thanks for the celebratory button. I'm back. Yes. I don't know why that happened. I think I turned OBS on before plugging the HDMI. So that could be the reason. Sorry about that. Apologies. Um yes. Okay. Let's do another test. Yay, look at this. So I'm sure you remember that in the advanced NLP spring semester course, there is an assignment. If we go to the assignment part, there's an assignment called Build Your Own Llama. I don't know if I'll be able to do it or not, but yeah, there are there are no details here. Most of the detail is in on GitHub. So yeah. For some reason, I don't want to do any prep because I don't know. If I did, then someone in the future that wants to do this and maybe like, I don't know, watches the videos, they'll be like, okay, but you did stuff without us knowing, because that's how I feel sometimes when I see tutorials. So yes, I did go through this during last stream. I'm gonna go through it again because I barely remember anything. Not the last stream. I think it was the one before that, but still. And I'm gonna try and do things on Colab and not on local device, and just see, you know, if I can do anything. If not, oh well. But I was actually planning to use maybe support from. I mean, obviously I can Google stuff, but like the only thing I'm not gonna use is look at what other people have done, because I think this is what that is. But I'm probably even gonna use ChatGPT if I feel like it. That is that. So, this assignment, this is an exercise in developing minimalist version of Llama 2, part of Carnegie Mellon's course, yes. We will implement some important components of Llama 2 model to better understanding its, to help us understand its architecture. We'll perform sentence classification on SST and CFIMDB. CFIMDB is a database. I guess that's also a data set with its model. I remember making a joke about DB dataset. Yeah, okay. I remember stuff, I suppose. Your task. The code is to implement can be found in llama.py, classifier.py, and optimizer.py. You're responsible for writing core components of Llama 2, one of the leading open source language models. True. In doing so, you will gain a strong understanding of neural language modeling. We will load pre-trained weights for your language model from stories PT, an 8-layer 42, I'm guessing million parameter language model pre-trained on tiny stories. So we are loading pre-trained. Is that what I'm doing, or is that what's already out there? A dataset of machine-generated children's stories. This model is small enough that it can be trained without a GPU. You are encouraged to use Colab. I'd like that. Or a personal GPU machine like a MacBook to be able to iterate more quickly. Okay. I'm guessing I should take everything to Colab. Does Colab allow like reading from links. I'm gonna check that after I go through this. Okay. Once you have implemented these components, you will test your model. Okay, I'm not there yet actually, but important notes. Follow the setup dot sh to properly set up the environment and install dependencies. There is a detailed description of the code structure in StructureMD, including a description of which parts will need to implement. So this is for us, okay? You are only allowed to use libraries that are installed in the setup. No external libraries allowed like transformers. Okay, that is evaluation. This is for output. Submission not yet. Prepare submit.py. Grading. Okay. All right. So I'm gonna go to Colab while hiding the screen and just see if I can Colab. If I can get the code, and I'll tell you how, I promise. Just not so interested in doxing myself. I think so far this is safe. So Colab open, it tells you if you want to open your old stuff. This is old stuff that, yeah. So if I say, oh, see, we have from GitHub, but not my GitHub, you know? So if do I take, well, it's not that, but do I take this URL? It says URL. Ooh. No? Oh, okay. Didn't work? Yeah, that's true. No. Why can't you see the assignment part? Oh, that's it. That's what I want. Minllama-assignment. So why? We didn't get it? Well, I can do the CLI thing, I suppose. No way, I can't. Whoops, that's not what I wanted to do. Okay. Upload, not notebook, not really. No. I don't want to do that. Okay, let's go new. Don't stop. This is fun. Not what I wanted. Okay. Insert? No. Do I go back to the main thing? Well, nothing unsafe here as well. But if I go back to Colab one more time, I don't wanna, so that I have access to it. That's a good point. It's a good point. I just thought I could just copy it without having to, see, it says search by organization or user, but I don't know why it doesn't see the stuff. It saw it actually, but I don't think this is what it wants, but let's try that. This is for Git. No, that's not it. Can you tell I've never done this? All right. Is there? I mean, it's README. I can download and upload. I think I might do that. Or yeah, like, you know, let's try doing. Will it? Yeah. Let's try forking it, and then see if that helps. But because, like, how would it know it's mine? It shouldn't. Doesn't have to. It did look like I found it at least. Huh? It did look like, yeah, it did find it. Yeah, it does find it, but nothing comes of it. I mean, it's meh. Okay, I can authorize it. Authorize collab. We can do that. Let's authorize collab. Even though it's not private, but at least I can say I can authorize it. Thou has been authorized. Now what? Like what do I do? Yeah. What do you mean there's no path? This is the path. I think my mistake is that I'm searching by. Go. I mean, you already know the stuff that I have. So, oh, none of them are. Oh well, I'm just gonna download it. It's fine. I'm gonna download my own thing, and then I'm gonna put it. Is there a notebook file there? Should there be a notebook file? Of course there are. No, they're all .py. Oh, there. We have an NPy at least. We have MD. Why wouldn't it read MD? But no, they're all .py. You're right. Can it not read .py? Interesting. I'm just gonna download the code as a zip, and then it is here, and I'm gonna go to upload, browse. There are none. There's one though. There's still one. It really cannot see any of them even when I'm trying to upload it. I guess that's the issue. What about .npy? Isn't npy supposed to be a notebook? That's odd. I can't see the zip, and even if when I open the folder, I can't see anything. Well, we can have a new notebook and just drag code there. I don't mind. I do not mind at all. Because we're supposed to first do the setup dot this here. So I can just say, just put it there. We can have a sure. This is the setup, and then that's the code for the setup, and then we run it, and then we close it. That should work. Extension for the notebook was IPy. Oh, Conda. This is for not online. Llama homework. Is that supposed to be like an environment? I'm gonna hide you guys away for the time being. Or just do pip. I don't think that would work though. I don't know what I'm doing. This is very much fun. I-N. Whoa, that's a lot of words. I don't think this will work. I'm gonna comment you because I don't think that will work. But for this, maybe pip should work because it's install. I have no idea. Let's try. No. No. I forgot the exclamation points. Hi Doppler. What's up? I am right now in crisis. Does wget also need one? Oh yeah, they do. How cool. But we don't have conda, so I can't run this part. I am on the verge of hyperventilation. I'm kidding. I just get frustrated when I don't know stuff, which is a lot of times. Yeah. Right now is one of them. So if we go to structure MD, what do we do about structure MD? This file contains the llama model, whose backbone is the transformer. We recommend walking through section 3 of the paper to understand each component. We've done a pretty okay walkthrough. There's an error. Yep, PyTorch is not there, I'm aware. Wait, what do you mean it's not there? Anyway, it's going for now. The multi-head attention layer of the transformer. This layer maps a query and a set of key value pairs to an output. Yes. The output is calculated as the weighted sum of the values, where the weight of each value is computed by a function that takes the query of the corresponding key. To implement this layer, we need to do this. Really? The instructions are a bit long. Live coding is scary. Tell me about it. Trying to do exposure therapy. When it's something like that you can't do in your sleep. I actually understand what you mean. Like, I'd rather live code something that I know instead of something that I don't know anything about. Okay. I'm too lazy to like record myself, edit it, and then put it up. So yeah, live streaming is what you get. Sorry. To implement this, we can linearly project the queries, keys, and values with the corresponding linear layers. Okay. Don't know what that means, but sure. Split the vector for multi-head attention. Follow the equation to compute the intended output of each head. Concatenate multi-head attention output to recover the original shape. I mean, theoretically, I understand, but not. Okay. Llama uses I 50% understand, but yeah. Modified version of this procedure called grouped query attention, where instead of each attention head having its own query, key query, and vector, query key and vector head, some groups of query heads share the same key and vector heads. To simplify your implementation, we take care of step 1 and 2 and 4. Oh, that's sweet. 1 and 2 and 4 are taken care of. 3 is what we should do. Follow the equation. You only need to follow the equation to compute the intended output of each head. Okay. This corresponds to one transformer layer, which has a layer normalization of the input, root mean square layer normalization. I sort of know what root square mean square is. Self-attention on the layer normalized input. Oh, there's text. Hi. It's good for the viewers, I think. Many that are trying to learn coding see polished videos. Yeah, when they stumble themselves, they might give up. Yes, those polished videos scare me as well. Yeah, those like 10-minute videos where it's like a month's project and it's explained in 10 minutes, just person showing code and then explaining it very quickly. Those scare me. It can be reassuring to see that even very smart people, haha, are born knowing everything and need to learn and troubleshoot and work through stuff. Yep, 100%. Who is very smart people though? People. Yes. Smart, less. Square all elements, add them together, and take the square root to result. Yes. Because I was thinking root means square, error. The thing that yeah. Square, add them, square root. Who thought of that? Self-attention, okay. A residual connection. Wait, all of this has to be... All of it? Or is that like a different thing? Oh, so the attention number 3 is needed. Got it. For the llama layer, let's see what is needed, because I hope it's not everything. Which for 2-dimension is like PyTorch? Pythoras? I don't know what you mean by that. Pythora? Or is that a different name of the same function? So feed-forward network on layer normalized output and self-attention, a residual connection from unnormalized layer. Ooh, I have no idea what this means. These stuff are supposed to do. Very fun. This is the llama model that takes in input IDs and return. Okay. We have a llama layer and then llama itself, the model. Input ID returns next token prediction and contextualized representation for each word. Takes input ID, returns next token prediction, and contextualized representation for each word. The structure of llama is... So you're just telling me about the structure. You're not telling me what I should do yet. Length of the diagonal of a right angle triangle. Oh, Pythagoras theorem. Yeah. Okay. Pythagoras, we used to say. Yeah, Pythagoras theorem, I think. Okay. So for an embedding layer that consists of token embedding, okay. See that I can understand because it takes input IDs and we have the token embeddings. Llama encoder layer, which is a stack of hidden layers, and the llama layer, a projection layer for each hidden state, which predicts the IDs for the next word prediction, a generate function which uses temperature sampling to generate long continuation strings. Note that unlike most practical implementation of temperature sampling, you should not perform nucleus top K sampling in your sampling procedure. Why? Okay. Desired outputs are logits over the vocabulary, predicting the next possible token at each point, and hidden state, final hidden state at each token in the given document. So now we are in what we do where. Oh, hi, JSS is here. What's up? Well, expect it's mean for RMS. So there is a scaling of the sum by the number of dimension elements, which I forgot. I see. Cool. I sort of like understand what you're saying. We're changing dimensions. So the components that require implementation are components with to-do. Details can be found in the code blocks. So read all of this. I will check my sanity later. Don't feel like it right now. Oh, there's a sanity check.py. Isn't that sweet? It will reload to embeddings. You are free to reorganize the function inside each class, but please don't change the variable names that correspond to llama 2 parameters. Okay. Inverse scaling. Meaning going down, right? Or, I was thinking we're going down, but okay. I was about to say, have you read the 3-body problem and then book 3, but let's not go into spoilers. So, okay, you have it? Yeah. Oh, you've seen the TV show. TV show is book 1. There are 3 books. Yeah. It's fun. It's really fun. The books are very different because the main character is a guy, is a dude, but the main idea is same. On your... All right. I am ahead of you. It's on your TBR. Yeah. I don't know why, for some reason, I had gotten book 2 before book 1, and I was like reading it, and I was like, what is this? And then I realized it's part of a series. Like, that was very dumb of me. Oh, hi, Ed. What's up? We have 2 cool people on the YouTube side and 2 cool people on the Twitch side. Now fight. That was a bad joke. Yeah. Dark Forest is book 2. Oh, I forgot book 3. But yeah, 3-body problem, the Dark Forest. Even like I learned about the Dark Forest thing. Is that it's not a is it a theory? I guess it's a theory if you think about it space-wise. But yeah. I learned about that through the book. Also, I learned about the 3-body problem, I think. I think I learned about the 3-body problem. Yeah. Can we use Llama 3? I mean, technically no, because this is a homework. But if you want to test this on Llama 3, that would be interesting, huh? Because this is Llama 2. Classifier.py. So, according to the so we have the to be implemented, all of these. Where are they? Okay, so classifier.py, optimizer.py, rope.py, nothing to be modified. All right, so we have 3 files that require modification. Is there no AI in the 3-body problem movie, book and TV show? I guess there isn't. Breaking is the best way to learn fixing. That's a really good point. I am way too scared to break stuff. Yeah. I am not the person. I don't know why though. Like, oh, hey, why can't I? No, well, I can't right click. Okay. So let's go to classifier.py. We can come back to structure.md anytime. do we just make a new, like what do we do? This is okay. Hopefully. What is this supposed to do? Is this supposed to make a file? I don't, or a folder? Okay. I'm very sure. Oh yeah. The character in the game world are AI. Wait, they're not. Oh wait. The, what is it called? Are they? I guess they are. Creates an environment. Thank you. Aren't they supposed to be, oh, I forgot. It's not photon, but you know the thing. The thing that it's supposed to be instantaneous communication between the two worlds. So I don't think, is it supposed to be? I mean, the game itself is, I don't know, but I thought they were real creatures. Not really. I don't know. I guess I've forgotten some stuff. So our to do is this part. Yes, that's the only part. Feed forward? Is that what it's supposed to be? These are classes. Whoa. I feel weird putting this in a notebook. This is real Python code. So, oh, I should definitely give it a title. Header, someone, this is supposed to be, I think we were just forward pass. All right. So that's that. Oh, we don't have an original model. Where's the original model? What else should I get before? I mean, I still can't run anything, but we have llama. Do I have these files in the file structure? Do I have upload? I'm gonna try and upload some of the Py files and see if that helps. Which automatic differentiation creates a backward pass. You don't supply backwards method. I'm gonna upload some of the code here. Like, I'm gonna upload everything. Don't know if that's a good thing. I don't think we need the data because we already just added it. Yeah. I don't think I need the license part, but I'm gonna just bring everything here. I'm getting a warning. Ensure files. Oh, that's fine. They're not. Wait, really? They're not runtime files. We have an error? Why? Are there too many things here? I can delete the license because it's from GitHub. Sure. Can you go now? The NPy is not coming. Don't know why, but yeah. So I can open this here. Oh no, I can't. It doesn't look good. Well, that's fine. But at least the import should work. No? It doesn't see this structure? Forward is what code runs for inference. Okay. Really? It also may be used as the base for code that calculates the gradients used in backpropagation. Okay. So this class is the classifier. These here are not working, which is a bit frustrating. We have a zero-shot classifier. We have the config, the tokenizer, the labels. Go run the code. And where's the yellow underline? Okay. That's, I'm sure, well, I mean, if we get a not, I don't know, I'm not calling anything. Well, thank you for the encouragement. I guess if I call this, then I'll get errors, right? Wait, where was that? Oh, sorry. So we should worry about backprop? I can try to do it for you, but even so, it can make it hard on it. All right. So we have forward here for the llama zero-shot classifier, and then we have llama embedding classifier, and then there's a forward. So each class has its own forward. Just taking the module, label names, load pre-trained. This is the llama for each param. Pre-train. Something about dropout, and then classifier head is a linear with the dimension and the labels. Find the hidden state after the final token of the input sequence. How? Is one just supposed to know how to find the hidden state? Because, like, we have logits here, but I don't think these are hidden state stuff. After the final token of the input sequence. So we have, but these are input IDs, not sequence. I guess that's the same. But logits are technically outputs. So that's some limits to what code you can put in forward to autodiff to work, I think. Okay. I might be doing what I said I would not do, which is go look at other people's solutions. Apply dropout, which we see it being applied here. Oh wait, what is that? No, that's from config. To hidden state at training time to mitigate overfitting. Sure. That is... Maybe print first what is input IDs and shape, see what it can do with it. Point is, this code is like a template right now. It's not really working with anything. There's a sanity check that helps you run the code. This here. We can try doing that, but I'm sure it will tell us that we did not. Let's put sanity check here as well. sanity check. And then if I put the code here, I'm sure it will say it's not implemented because I've done nothing. Yeah, not implemented, error from forward llama.py, which we weren't even there. But I am happy that I can read the stuff, so that's pretty good. We didn't even do the llama.py. Oh, root mean square normalizer. See, now here it tells you what arguments you should use and what return. Was this telling me what arguments I can use? No, you assume too much. Or at least we have this self.dropout here, and then self classifier head. Oh, whoa, look at that. Hidden states. Where did you get that? Sent IDs. But if I do that, you know what? I'm gonna do that. If I do that, are we calling llama? We are not calling llama exactly. Where is this llama coming from? Oh, load pre-trained. Huh. But then, are we loading pre-trained? Yes, we are. Okay. So I'm gonna also do that. Why are you giving me an error? Oh, issue with tab. Sorry. Here, happy? Not really. There's an extra space. No? One tab, two tabs. Happy? Fine, I'll take you up there. Oh, still not happy. You're kidding me. But that after the final token of the input sequence, I don't know what that means, but at least I know logits, and I suppose hidden states are things that exist. And then the dropout thing, I'm probably going to steal from you, but what do I do with it? To the hidden state. We apply it to the hidden state. Not this thing, but the actual hidden state. I don't know if that's right, but I'm going to do that. And then pass this through. We have self dropout. Do we pass this through the classifier head, which is something that I see here, which will return logits unnormalized probabilities over all classes. I think when you copy from GitHub, it uses space instead. You need to really? Really? So if it's a tab, then it will 1, 2, 3, 4. Oh, they are indented differently. 1, 2, 3, 4. Space? Huh, it's all spaces. Well. At least it's not giving errors like the thing. We'll get there. Yeah, it's fine. think so. Annoying but interesting. I can take like this here and hope that, or like this here, but it says 2. Are we 2? No, it's not. Oh wow, it shut up. Okay, so just use whatever indentation is there. Just use the same thing. I guess we're supposed to use the classifier head, but oh, I don't think we're supposed to do a linear layer, but I don't know. So I'm gonna take you, put you here. Pass this as in I don't know if it means this, but I am passing it through the classifier head. Are we going to do the same thing that this is doing here? I don't know. I mean, I can just do that and when I get an error and be like, oh well. And you're telling me that it will return logits. So how do I pass it? Meaning I should expect logits. Like sort of update this like that. And then since classifier head is this part, do I pass it through this part? Take the log max of the logits and return log probabilities over all class. Log max, someone's already done it. Hee, that's fun. Sure. So I should probably do some sort of like, supposed to be number 1, supposed to be number 2, but is it? Probably not. Supposed to be number 3, but we're not there yet. And then supposed to be number 4. I stole it somewhere. What did I do? Self is not defined? Yes, it is. Are you mad that I'm guessing you're mad that I have no indentation now. You're okay. You're not okay. You are okay. Okay. I don't know what we should do here. We sort of have logits. Should be an output. Classifier head. Do you take? You're a variable, no? You're not supposed to. Where were you defined? Were you defined? No, you're just, I mean, sorta. We have dimensions. We have labels. Here, this is about overfitting. I think I will. I don't know what I'm doing. No, Oh, hey. We do have it from the constructor. Yes. I think maybe you have to call it rather than reassign it. Okay, but apply dropout to the hidden state. How? Because I did this thing. Dropout to the hidden state. And then do I not reassign it? You're right. It's already doing what all of the other stuff. So here I can do this instead because you're right. There are some stuff that's already there. The llama is already pre-trained, so I don't need, I mean, it's already loaded. I don't need to load it again. There's an example. So output of it can be used as, why not? All right, sure. So you say I can use dropout like this. If that's the case, then we can also use the classifier head and pass whatever it is through it, apparently. So this is 2 and 3. Am I doing wrong? Maybe. But it says it can be done. But now what? How do I assign it? So output is supposed to be logits. So I can just actually take this here. And then do the log probability, which I stole from here. We did something? Second thing would be, yeah, it looks correct enough. Whatever. Here, by finding, I guess this should, I don't know, whatever. I don't think this is right though, but it's fine. Thanks for that. Did not know you can use it as a function again. That makes it, yeah, more helpful. So I don't know if I am being mean, but like there's a really high possibility of me ending the stream in like less than 10 minutes. Apply input ID to llama just like top one. What do you mean? Apply input IDs to llama just like the like here? Input IDs? So that hold up. Oh yeah, we have it. You're right. Do we? Yeah. And then the output is logits, and then this thing, they didn't take it. You're actually right about this one. That feels more correct now. Interesting. Very interesting. Let me save it, even though it's supposed to be auto-saved. Min-llama-assignment is the title of our notebook. So was that classifier? That was classifier. And then after classifier, I am not sure about anything right now. Load a pre-trained model. We did that. No. Llama sent classifier, that also exists? Or was that inside it? No, that was the function that we sent. No? Nope. Do we have sent classifier? No. That's good. And then optimizer. Oh, hey, Adam W. Yeah. I know that guy. Oh, we have an optimizer.test. Test. That's good. Optimizer. Ooh, that's cool. Is that the to-do? I don't see any to-dos. If I don't see to-dos, I'm not gonna do it. But we have a not implemented error, so does not support sparse. Anyway, I'm gonna run away right now. Like I am gonna run away. I'm not gonna apply. I don't think I will. I don't have the energy. It's supposed to be optimizer.py. From home? Not yet, no. I, let's put that as a to-do. That's a to-do. Okay. If I run away from home, I will starve and probably get sick and everything. I cannot maintain myself. Thank you. Oh, Adam W is the skinny guy, right? Oh yeah, because of weight decay. That's funny. That is good one. Is the only Adam movie actor is to do? Like ta-da? When to do is finished, it becomes ta-da. Yes, that's the evolution. But yeah, I don't know if anything will work, but we tried. We have the setup, we have the classifier.py, and then the to-do one is the optimizer. Next, like something tells me like I'm gonna have each one be one stream because my brain is not cut out for this. You know what? No. I was like, you know what? Let's cheat. Let's not cheat yet. Let's not cheat yet. We will cheat maybe when it comes to running the code. And then we get errors, and then we will see what other people did. I think then I will allow myself to look at what other people have done. Yes. Oh, we have Gemini to help. I forgot. All right, we can ask help from Gemini later as well. Yes. When we get errors, because it's not even if, it's when. Embrace it. Sure. Thank you. That's sweet. Okay. So thank you for enduring my horrible schedule, which is on the mend. It's about to get fixed, inshallah. Pray for me. And then I'll try to do this assignment. I'm not supposed to use anything HuggingFace, so we're not going to use that. So funny, we weren't born to walk, but we did. I mean, yeah, we weren't born with walking abilities, but we learned it. Yeah, I'm sure there's a Vsauce video that says the human body is like so optimized for running or walking or whatever. And then you're like, but why do I get tired when I do it? Yeah. Brains. I actually do like errors. They tell you where there's a problem much better than cryptic silent failure. Someone's done a lot of JavaScript. Oh yeah, that's actually true. There's a saying that says, I'm very sure English has it, but I was just thinking in my own language. If you don't fail, you don't learn. And the actual thing is, if you don't fall from a horse, you're never going to learn to ride. That's the thing. Yeah, we are falling and tumbling and hopefully somewhat learning on my side. And you guys, thank you for the help. Buddy's a machine. Machine is now buddy. Yes. Brain is also machine. Errors are helpful, I agree. Until segmentation fault enters the chat. I don't know it. I do not want to know it. Who dis? New phone, okay? Okay. Thank you. I'm not gonna take up more of your time. My brain is currently overheating. Maybe it's because summer, maybe because I'm yeah. Probably gonna watch some stuff to get myself back on neutral. Okay, inshallah. See you tomorrow so that we can try to finish the rest if we can. Oh, good night. Wow. Okay. And I'm gonna, yes, brain relax time. I'm gonna end the stream in after 5 countdowns. If there is, if there is anything else, let me know. Otherwise, see you next time, I guess, or see me next time. Yeah, ending in 5, 4, 3, 2, and 1.